In this video, we discuss about Domar model. A Russian-American economist F.C. David Domar, April 16, 1914, April 1, 1997, builds his model from both demand as well as supply side based on the dual effect of investment and provided the solution for steady growth. It is a double-sided model. So demand and supply side both are important in this model, and here we try to explain the dual effect of investment, and it provides the solution for maintaining steady growth. To simplify the model, the demand and supply equation in the incremental form can be written as follows. The demand side of the long-term effect of investment can be summarized and expressed through the following relationship as delta yd equal to delta I. Delta I is I by alpha. Delta yd is a change in income. It equals the multiplier times. Multiplier times means 1 by alpha. That is the multiplier times 1 by alpha. The change in investment. Delta I into 1 by alpha. Okay. Change in income equal multiplier times change in investment. Delta yd equal delta I into 1 by alpha. Or delta yd equal to delta I by alpha. Okay, both are same. Where alpha represents the marginal propensity to save. Marginal propensity to save, which is reciprocal of multiplier. Which is the reciprocal of multiplier. The supply side of investment can be summarized and expressed through the following relationship as delta ys equal sigma into delta k. Delta ys is the change in output supply. Delta ys equals sigma into delta k. The product of change in real capital, delta k, and capital productivity. The product of change in real capital and capital productivity. Change in real capital is delta k and the capital productivity is sigma. Or delta ys equal sigma into capital I. Delta k equal to capital I is a net investment. I denotes the net investment. We substitute I for delta k. Equilibrium for steady growth. For achieving steady growth, the aggregate demand and aggregate supply must be balanced as expressed below. Delta yd equal to delta ys. Demand side and supply side are equal. By substituting the value of delta yd and delta ys from the equation, we substitute delta I by alpha equal sigma into I. We substitute delta yd and delta ys with equations, or delta I equal to alpha into sigma I. We cross multiply this equation, dividing both sides of equation by I. We get delta I by I equal alpha into sigma I by I. Or delta y by y equal alpha into sigma. Since by the assumption of the model delta I by I equal delta y by y, both are same, we substitute delta I by I as delta y by y. The last equation, equation number 5, explains that if steady growth is to be maintained, the income growth rate delta y by y should be equal to the product of marginal propensity to save, thus alpha, and the productivity of capital sigma. Delta y by y equal the product of marginal propensity to save alpha into the productivity of capital sigma. Domar condition of steady state growth can be explained with the help of a numerical example. Suppose the productivity of capital is 25% and the marginal propensity to save is 12%. Then delta y by y equal 25 by 100 into 12 by 100. That means 3 by 100 or 3% is the delta y by y is 3%. or delta I by I is 3%. Thus, the above numerical example shows that the income and investment must grow at an annual rate of 3% if the steady growth is to be maintained at full employment. Any divergence from this golden path will lead to cyclical fluctuations. Disequilibrium reflecting non-steady growth state would prevail if delta I by I is greater than alpha into sigma and the economy would experience inflation. The other disequilibrium condition is delta I by I is less than alpha into sigma. The economy would suffer from secular stagnation. A diagram representation or a diagrammatic representation of Domar model is that as shown in the figure, the x-axis represents income and y-axis is saving and investment. The 45-degree line represents a saving line. Saving is the function of income. Then these slanting lines are I0, I1 and I2. The line SY passing through the origin indicates the level of saving correspond to different level of income. I0, I0, I1, I1, I2, I2 are the various levels of investment. Y0, P0, Y1, P1 measure the productivity of capital. Y0, P0. Then Y1, P1 that representing corresponding in the different levels of investment. The lines Y0, P0 and Y1, P1 are drawn parallel so as to show that productivity of capital remain unchanged. The level of income Y0 is determined by the intersection of saving line and the investment line I0, I0. At the level of income Y0, the saving is Y0, S0. When the saving Y0, S0 is invested, it will increase the income from OY0 to OY1. That's the increase in income. The productive capacity will also rise correspondingly. The extent of income increase depends upon the productivity of capital, which is measured by the slope of the line Y0, P0. Higher is the level of income, higher the productive capacity. Similarly, the level of income is OY, the level of saving is S1Y1. With investment S1Y1, income will further rise to the level Y2. This increase in income means the expansion of the purchasing power of money. Then the comparison of Harrod model and Domar model. There are some similarities in this both models. The models are based on some similar assumption. It is for the reason the name of Harrod and Domar are clubbed in any discussion of growth models. Both models employ Keynesian saving investment equality as a condition of the steady growth. Then both these models stress on knife-edge equilibrium. Both the models are built in the context of advanced economy. The advanced economy, there is the abundance of capital. As against the Keynes macrostatic theory, Harrod Domar hold that a dynamic approach, they focused on a dynamic approach to growth, should be introduced in long run. Then dissimilarities, Domar again assigns a key role to investment in the process of growth. Then Harrod regards the level of income as the most important factor in the growth process. Domar forges a link between demand and supply of investment, while Harrod equates demand and supply of savings. Domar model is based on the growth rate alpha into sigma, but Harrod uses the three distinct rate of growth, actual, warranted and natural. Domar give expression to the multiplier, but Harrod uses the accelerator about which Domar appears to say nothing. Domar assumption that delta I by I equal delta Y by Y, but Harrod does not make such assumptions. These are the dissimilarities of Harrod and Domar model.